Hello class, so what we'll do now is we will look at the 2018 final exam paper. I will provide you with the solution and I will give you extra justification as to how a problem is solved and why I've used it. I'll talk about referring to tables and so on. So in this video I'll only look at the theory part of 2018 final exam paper, and then in the following videos we'll look at questions from section B. So question 1 from theory. So question A1, you are required to transfer power between two perpendicular shafts using gears. Which gear would you choose to accomplish this? So the first part is you have to choose a gear for transferring motion to two perpendicular shafts. Then in addition to this, if you are also required to minimize the noise and vibration, which gear would you use then? And you have to explain. So first things first, for transfer of motion between two perpendicular shafts, we will use bevel gears. Then for the second part of this question, it says if you are also required to reduce noise and vibration, you will use a spiral bevel gear. The reason for using a spiral bevel gear is that they have greater tooth strength and cater for larger load carrying capacity. Tooth engagement starts from one end to the other, hence the operation is smoother, and therefore what happens is the noise and vibration is negligible. So if you want to transfer motion between two perpendicular shafts and at the same time ensuring that noise and vibration is minimized, you'll use a spiral bevel gears for two reasons. Tooth engagement starts from one end and goes to the other, therefore the operation is smoother. So when the operation is smoother, there is no vibration. If there is no vibration, there is no noise. So I hope you understand as to what this question was actually looking for. Moving on, what you're given is you're given a deep groove ball bearing, and you are to identify parts A, B, C and D. So when you look at this, what happens is A is the outer ring, B is the inner ring. When you look at C, you'll see that C is the retainer. The retainer contains the spherical balls in it, and it is equally spaced around the circumference of the inner race. Then what happens is D itself is the spherical ball, or you can just simply say a ball. What happens is when you look at this, when I look at this region here, so sometimes I can also ask you as to what this portion is. That is known as the outer race, and this is known as the inner race. The outer and the inner race is the groove that is cut into the inside of the outer ring and on the outer side of the inner ring, and within these grooves the spherical ball is able to move freely. So the ball does not move in the outward direction, in the sense that it does not come out of the bearing setup. So what can happen is you can be given different types of bearings, so it is very important that you understand some of this nomenclature. Now later on I can also say that what is this distance, or what is this inner diameter called, so that is known as your bow. So whenever you select a bearing, we always look at the bow, and bow is the inner diameter of the bearing. So that's how we always select bearings. So later on when we look at bearings problem, when we look at bearing selection, we always select a bearing with respect to its bow diameter, and bow diameter is basically the diameter of the inner ring. Moving on, let's look at A3. You have to differentiate between a mechanism and a machine. So this is a little bit tricky, but the definition is already given to you in your lectures. So what happens is the sole purpose of a mechanism is basically to convert motion or transfer motion. And what happens is when one of the links of the kinematic chain is fixed, the chain is then known as the mechanism. And mechanism is a combination of rigid or resisting bodies so shaped and connected that they move upon each other with definite relative motion. So mechanisms, the most simplest mechanism is a 4-bar chain, and in a 4-bar chain we fix one of the links and we can get a mechanism which transfers motion. One of the most simplest, maybe one common example of a mechanism could be a slider crank mechanism. Slider crank mechanism converts rotary motion to reciprocating, or vice versa. And you can see this slider crank mechanism in car engines, right? So that is a mechanism. Then on the other hand, what happens is, so what is a machine? So in simple, a machine is a mechanism or a collection of mechanisms which transmits force from the source of power to the resistance to be overcome, and thus performs some useful work. So in general, when you look at the last point, it simply says that when the mechanism is required to transmit power or do work, then it becomes a machine. So a mechanism is just only used for transferring motion. It does not do any useful work. Whereas if that same mechanism is required to do some useful work, transmit power or transfer power, then that mechanism becomes a machine. So what we can always say is that a machine is a mechanism, but we cannot say that a mechanism is a machine. So I think in one of past exam papers I had asked that, is a machine a mechanism? Explain. Then you should be able to explain that a machine consists of mechanisms, and the sole purpose of a machine is to transfer power or do some useful work. Therefore a machine is a mechanism. So these are some of the things that you need to keep in mind. Moving on to question number 4, it says that internal combustion engines can be classified in a number of different ways. You are to discuss two of these with examples. So just don't write, right? So what we can do is, I'm just giving you pointers, but you need to explain. So when the question says that give list two of these classifications with examples, you need to list the classification and then give example. For instance, they can be classified in terms of type of ignition. So if you just write type of ignition, you don't get full mark, right? Or if you write engine type, you just don't get a full mark, because in type of ignition what we have is, we've got a CI and SI engine. So CI is a compression ignition engine or a diesel engine, and SI is a spark ignition or a petrol engine. So you need to explain this. Now what we have is, we have engine cycle. When we look at engine cycle, we've got 2-stroke and a 4-stroke. The next classification is basic design. So in basic design, what we have covered in our lectures is basically looking at a reciprocating engine and a rotary engine. So rotary engine, a good example of a rotary engine can be seen in a Mazda, I think it's RX-8 series. So it's also called a Wankel engine. And then what we have is, we've got position and number of cylinders. So for example, we can have a straight cylinder configuration, a V cylinder configuration, or a W cylinder configuration. Then what happens is, the cylinders, they can be opposed cylinder or opposed piston. So we've got boxer engine and so on. So these are the types, and then you need to list the examples as well. If you list types of ignition and just say engine cycle, you might get just 1 mark here, 1 mark there. But if you don't list the example, you don't get full marks. So please do keep in mind that you need to understand the question and then try to answer it. Moving on, it says that when a brake is applied in a moving car, it is observed that the brake pads heat up. Explain the energy transformation taking place when the brake is applied. And what happens is, why is the excessive heating of brake pads dangerous, and how is this addressed? So the first thing is, you need to look at the energy transformation. So what happens is, a moving car will have the kinetic energy, and then once you apply the brake, the kinetic energy is converted to heat energy, and this heat appears as increase in temperature of the brake pad. So that's your energy transformation taking place. So now it says that, why is excessive heating in the brake pads dangerous? So what we do is, we know that there is a phenomena which is called fading, and fading is simply the decrease in the coefficient of friction due to the increase in the temperature. So when a brake fades, its performance is severely affected. What generally would happen is that at a higher increase in the temperature, the brake loses its characteristics, it loses its coefficient of friction, so as a result of that it's not going to provide effective braking, and this can lead to dangerous situations. And in order to remove this heat, what we do is the brakes need to be vented. So what generally happens is ribs, fins, vents are provided onto the rotor itself. The brakes are not finned, right? The brake pads are not finned, but the rotor that is attached on the hub has got ribs, fins, holes in it to provide air circulation. So as the air moves past the brake pad, it cools it quite effectively and removes the heat quite effectively. The next question is looking at discuss the operating principle of a centrifugal clutch. So centrifugal clutch, the most simple application of a centrifugal clutch can be seen in brush cutters. So what generally happens is the schematic of a very simple centrifugal clutch is provided. So you've got springs, and springs are attached, or they hold the shoe, which is basically your friction surface. It holds the shoe in place, and then this is your driving, and this is your driven. So what happens is the driving shaft is housed inside the driven shaft, and what generally happens is the spring, when you look at this, the spring exerts a inward force, radially inward force. So what would happen is the shoe will try to move outwards as the rotating or the driving shaft starts to rotate, and that is due to the centrifugal force. So what happens is as this driving shaft starts to rotate, the shoe tries to move outwards due to the centrifugal force. So now moving on as to how the centrifugal clutch would work is, so again what we have is we have to take into account two forces here, right? We've got the spring force which holds the shoe in place, and then once the driving shaft starts to rotate, we'll notice that the shoe here will start to move outward. So you've got the centrifugal force. So when the centrifugal force is less than the spring force, the shoe remains in the same position. So now slowly the driving shaft gains speed. So when the centrifugal force exceeds the spring force, the shoes will start to move outwards. So these shoes will start moving outwards and eventually come in contact with the driven shaft, and it will press against the driven shaft. So what happens is the force or the force by which it will press against the driven shaft depends on the speed of the driving shaft here. So if the speed keeps on increasing, you will notice that the shoes, once they come in contact with the driven shaft, will press harder and harder against the driven shaft as the rotating speed of the driving shaft increases. And then what happens is, as that happens, it is able to transfer more torque and more power. The increase of speed causes the shoe to press harder and harder, enables more torque to be transmitted. And once the speed starts to decrease, the shoes will again start to move inwards, because the shoes will start to move inwards because the spring force is now becoming larger compared to the centrifugal force. Once that happens, the shoes will lose contact with the driven shaft, and what you'll notice is the driving shaft will rotate. However, the driven shaft will remain stationary. Let's look at question number 7. A group of engineers are requested to select either a belt drive or a chain drive to connect the drive shaft and the output shaft. One of the engineers suggests that they should use chains. So do you agree with this suggestion? And you have to explain as to why you agree or disagree. So basically this question is looking at your understanding of advantages of chain drive and belt drive. So for me, I would say that I would use a chain drive. So firstly, I would agree with the engineer engineer's suggestion, because chain drives offer certain advantages over belt drives, such as listed below. So in chain drives you have no slippage, therefore the we have a perfect velocity ratio. Since the chains are made of metal, therefore they occupy less space in width than belts. So you will notice that when you have belt drives, you need to have significant amount of cross-sectional area for given to that, or given for a particular belt. So when you look at belt drives and chain drives, you can see the chains are quite small in nature, so it is space saving tactic. Chains can be used for both long and short distances. It has a high transmission efficiency. It bears less load on the shafts. So again, just because it's smaller in nature, it will weigh less. Sorry, not weigh less, but it will have less effect onto the rotating shafts. Can transmit motion to several shafts by just using one single chain. You can loop it around. And then mainly the most important point is that it transmits more power when compared to belts. So this question was basically looking at your understanding of if you are able to uh, understand the advantages of belts and chains, and which one is much better. And finally, in part A, the last question was dealing with electric motors. It says that a synchronous motor has 4 poles and the electrical frequency is 60 Hz, and you have to calculate the synchronous speed of the motor. So firstly, the synchronous speed is simply given by 120 times F over N. F is the supply frequency and N is the number of poles. So in this case, the supply frequency was 60, so 120 times 60, and the number of poles was 4, so 120 times 60 divided by 4, you get a synchronous speed of 1800 revolutions per minute. So what I'll do is the section B of this paper, we'll look it in the another video. What I'll do is for section B, I will do 2 questions each, make videos of 2 questions each, so that I can explain and you get a you don't have to spend too much time looking for or watching the video. So small blocks of information for you to process. Thank you, and look forward to the solution for part B of the 2018 final exam paper. Thank you.